Hi, everyone. Today we are going to be talking about quadratics. So we have our warm up here. So first we're going to fill in the table using our given function. So we have f of x equals x squared, and then we have all of our x values over here. So first to fill those in, we want to make sure we're plugging in that x value. Make sure you use parentheses here. Okay, you have to use the parentheses, otherwise you'll get the wrong answer. Okay, so if we type this into our calculator, negative 4x squared, just like this, parenthesis negative 4, oops, squared, like that. Your squared button is kind of by your 7 key, number 7, and you hit enter, we get 16. So I'm going to put 16 in that spot. Our next one, negative 3 squared. If you type that in your calculator, you get 9. Okay, so go ahead, pause the video and complete the rest of the table and continue playing once you're finished to check your work. Okay, so we should get 4, 1, 0, 1, 4, 9, 16. Now we want to go ahead and graph the points. So we're going to first graph negative 4 with 16. So I can find negative 4 on my x, and I'm going all the way up to 16. That's where I will put my dot. So we're at negative 4 and 16, 3 and 9, which is between 8 and 10, 2 and 4, negative 1, 1. 0, 0, and we have something similar on the other side. Feel free to pause the video too if you need to get your points plotted here. Okay, so I want you guys to pause the video, take a couple moments and write down what do you notice, what do you wonder, and then you can compare with the people that you're sitting by. All right, once we're done with that, we're going to look at our questions below. So we want to connect the dots with a smooth curve. So it's going to be a nice smooth line. It does not need to be straight. It's going to have a curve to it. So if we look at our graph here, we're going to take those points and connect them just like that. So it kind of looks like a U shape. Okay, it doesn't have to be perfect, but we just want to make sure that we're not using straight lines. So all of our graphs in this unit are going to look similar to each other to have that U shape, okay? Either opening up or opening down. We'll talk about that more later. But what shape is made by these points? That is called a parabola. Okay, that's how you spell it, parabola. All right. Number 2, what is the lowest point on the graph? We've talked about this before. That is called our minimum. Okay. And on our graph, our lowest point is down here. Okay, so for this graph, we have 0, 0, and let's go ahead and label that on our graph. So we have 0, 0. That is my minimum point. Number 3 says, what is the domain of f? Remember, domain is talking about our input or the x values. So we don't have any limitation here. We could plug in anything we want for x because it's just x squared. We can put whatever we want into that value. So our input is going to be, for our domain, all real numbers. Okay. Then we want to talk about our range. So our range is for the output, which are the y values. So something that's unique about our parabolas is that they have this curve, right? So in this situation, there is a minimum. There is a lowest value that we have. And no matter what other points I plug in, it's either going to continue going up in this direction or up in this direction. Okay, so we're never going to have any output values lower than this because that is my minimum. Okay, so that means for our output, we can have decimals. So that means we can have all real numbers, but they need to be 0 or greater. Okay, because 0 is that smallest output value that we can have here. Okay. Number 4, we're being asked about where is F decreasing? Okay, decreasing means going down, right? So we're looking at our graph to see where is F going down. So it's going down on this whole side until we get to that minimum point. So that means that F is decreasing from negative infinity to 0. Okay, that is the X value where we hit that minimum. Okay. And whenever we're talking about decreasing or increasing, we're always using X values to describe that. So anything that is all the way over here on our negative side, because that's going to keep getting higher. So anything negative infinity to 0 till we hit that minimum point. Okay. And then where is F increasing? That means our graph is going up. So that's going to be from that minimum all the way on this side. Okay. So that means we are increasing from 0 to infinity, because no matter how many other X values I plug in on this side, we're going to continue going up. Number 5, does f of x have a constant rate of change? So remember, another word for rate of change is slope. Okay, so we saw slope back in Unit 2 when we were graphing our linear equations. Okay, so here, if we look, does our slope between these 2 points look to be the same as it is between these 2 points? Okay, those lines are at different steepnesses, okay, if that's a word. So it's really steep here and then not as steep here, okay? So this is not at a constant rate of change. So we would say no. And the main reason, you can describe however you want. You can talk about the steepness of the line between multiple points, or we can also say because it's curved, right? Any graph that has a curved line is not going to have a constant rate of change. Okay, so however you want to describe that in your own words is fine. Now we want to use, for number 6, a dashed line to draw a line of symmetry. So symmetry, if you remember from like art class and stuff, is where we could split something right down the middle and it's going to be the same on both sides. So if we look at our graph here, that's always going to go right through that point there. Okay. So we're going to use a dashed line. Let me use a different color and just draw a dashed line straight through my graph right there. Okay, that's going to be the line of symmetry. It's always going to go through your minimum or your maximum point. Okay, whenever we have this minimum or maximum point, there is a special word that we use to describe it. So yes, it is our minimum, but we also call it our vertex. Okay, the vertex. So that is the minimum or the maximum of our parabola, and our line of symmetry is going to go straight through it. Okay. And then our last question, we want to look at 2 x values that have the same output. So if we look back at our table, I'm just going to pick any 2. If we look at -2, 4, and 2, 4, they have the same output. Now remember, it's still a function because our definition for function is every input has only one output. So this is a function because -2 is only going to 4 and 2 is only going to 4. So this is fine. This is a function. But if we look at those 2 points, 2, 4, and -2, 4, if we look at those on our graph, those are right here and right here. And if we look at them in relation to this line of symmetry, they are 1, 2 spaces from the line of symmetry and 1, 2 on the other side. So they're that same distance, right? Which is why we have symmetry. They're the same distance on both sides, okay? So we could say they're both 2 units away from the line of symmetry. Okay, and again, if you want to use your own words there, that's fine. But that's just what we're looking for. They're the same distance, and that's true for all the points. If you look at 3, 9 and negative 3, 9, those would both be 3 units away. Okay, and same thing with 4 and 16. So go ahead and go to the next page when you're ready. So here we are given a graph. Okay, we already have our graph here, just like that. Okay, and our first question is, what is the vertex of the graph? Okay, remember the vertex is either the minimum or the maximum. So here, this is going to be our vertex. It's where our graph curves. So in this case, it would be the maximum. Okay, so we're looking at our x value here and the y value. So that would be negative 1, 2. That is our vertex, negative 1, 2. Then we're being asked, what are the x-intercepts? Remember, x-intercepts is where my graph crosses the x-axis. So we have one here and here. So we have negative 2, 0 and 0, 0. Okay, negative 2, 0 and 0, 0. Those are my x-intercepts. Okay. Does the graph have a maximum or a minimum? Again, that's always going to be talking about the vertex. Okay, since this point is the highest point on the graph, everything else is below it. That is going to be a maximum. Then we have, where is G increasing? So remember, that's where my line's going up. So in this case, we're over here. All of the x values this way would be negative infinity, and we are increasing until we get to that x value of the vertex. So we are increasing from negative infinity to negative 1. Then we have, where is G decreasing? That's where my graph is going down. So that would be the other side. Again, starting from that x value of the vertex, going this way would be positive infinity. So we would be decreasing from negative 1 to infinity. Okay. Then we're asking about the axis of symmetry. Okay. That line goes right through our vertex. So that's going to be a vertical line here. Okay, that would be our axis of symmetry. And anytime, remember from unit 2, when we have a vertical line, that equation is going to be x equals, right? X equals whatever that value is that it's going through, which again is that x value of our vertex. So x equals negative 1. That is that line. What is the domain of G? So those are our x values, the input. Okay, our domain for pretty much for all of our quadratics is always going to be all real numbers or all numbers. Okay, we're not really going to restrict those until we get to word problems where we have context. Okay, and then what is our range? That is describing our y values in this direction. So that's always going to be restricted by that vertex, which here is a maximum. So the highest y value we can have is 2. So that means my range would be all numbers 2 or less, because we can have 2. We have that right here. But we also have anything less than that, nothing above. And then our last question, which direction does the graph open? So we're either going to be opening up like we did in our last question, or we're going to be opening down. So in this case, our graph opens down. Okay. So I would like you guys to try the next one on your own here. Similar idea, but now our parabola is up here. Okay. So I'd like you to go through the same questions, and then when you're finished, check with your partner, check with me, and you guys are good to go. Let me know if you guys have any questions.